Hi everyone. So today we are going to go over an example of the math class that is included in the Java library, as well as wrapper classes, and how to use the static variables from each of these. I'm also going to do a brief example of what it looks like to declare a class that has a static and final options on a variable, and so you can see what that looks like a little bit. So let's start with the math class. So I'm just going to do a system.out.println here, and we're going to just print out one of the most common things to use out of the math library, which is the math.pi. Now, pi is, of course, the value. Pi is 3.14 with a bunch of extra digits, right? And if we just run that, you'll see in the output down here that it prints out the value of pi there, and it's something really useful so we don't have to define pi ourselves. Now, other things that the math library includes is things like the uh, absolute value. So math.abs allows us to get the absolute value of a value that we put into it. And it should return 2.5, and if we compile it here, you will see that it does that. Other things that it includes is something called random, so system.out.println, and then math.random will return a random value to us. Now, I don't necessarily suggest using this particular random value. It helps if I spell things correctly. I don't recommend using the random method from the math class for things that need random, particularly for security reasons, but there are other random methods that you can use. So you can see that it returned a random value to me, and it actually returned a random decimal value. It did not return an integer value to me. So that's important to remember if you're going to be using that. There's a bunch of other options that you can use, but you'll note that every time that I did this, I didn't have to instantiate an object of the math class. Instead, I just used the name of the math class in order to do this. That's because they are all declared using the static and perhaps static final approach to the methods and to the variables that I called here. So that's what it looks like when you're using them and you can't see inside of the class. Next, let's talk a little bit about uh, the wrapper classes that I mentioned before. So if we're working with primitive types, normally we're going to do something like int I equals 5. But if we're going to put something into a wrapper class or box it, then we're going to do integer, and we'll just call it j is equal to I. So this is boxing that primitive type I into j. And if I wanted to compare these, I actually can do that directly. You'll be able to do that by doing system.out.println just so that we can see the result. And we can do I equals j. Now normally this kind of thing wouldn't work, but because of the nature of wrapper classes, it's automatically doing that conversion for us, and you can see that it actually returns a value of true. So this is something that's really neat about wrapper classes that you can't do with most classes, as it's just not a feature that you can compare it to something that is not of the same type. But again, wrapper classes are special. Now, other things you can do is we're just going to, again, do a system.out so we can see results here, .out.println. We are going to do an integer max value. Now this gets us the maximum value that we can store in an integer, so it helps us make sure that we are not getting an overflow error. Now you don't have to use the integer class like we did with the math, but you can. You don't actually need j to exist for this to work, and you could use j if you wanted to. They both are going to return the same thing, and that's going to be this large number you see down here. Hopefully you never actually have to write a program that goes up to numbers that high, but some of you may. So that's how wrapper classes look. Now, if we wanted to actually declare a variable with a static variable, so an instance variable with a static keyword, we're just going to do that by saying that we want a static int, and then we're just going to call this, let's call this z. right? So if we're going to call it static int z, then we can do something down here where we would do z equals, 5, right? That's going to allow us to set it. But if this was any other class, if we're getting that static value from any other class, we wouldn't have to instantiate the class. We wouldn't have to use that new modifier. We could just use a class name like we did with math to get the value of it. So we would just do something in this case of something like main.z, and we'd be able to print it out. Now that's not going to work here because we're within the class that's using it, but that's the general idea of what a static would look like. Now if we wanted to make it so that it couldn't ever be changed, we can do static final int here. And I'm just going to go ahead and say that this is public. And then we're going to have to set it, when we use that final, we have to set it right away. So we're going to set it to 5. And that's the idea behind the static final and the static that I mentioned before. So make sure that if you use that final keyword that you are setting it when you're declaring that variable, or else it's just going to be instantiated to the default value and you're not ever going to be able to change it. So that's the basic idea of how we use static values and methods and how we use wrapper classes. So make sure, I will again share this code with you on iLearn, so don't worry too much if you can't really see it. It will be shared. Make sure you look for it there.